How y'all doing? Got a new paper here. Accretion friction braking part 2. 25143 Itokawa. That's the Japanese guy's name who discovered it. In this paper, calculations are done to determine the kinetic energy in joules of an impact at 3 different velocities of the asteroid. More calculations are done in the graph, and some explanation is given as to what will happen to Itokawa in accordance with the general theory of stellar metamorphosis. Essentially, any impact of velocity of Itokawa due to its large mass will cause enormous destruction, leading to the realization that it must have formed from an even larger destructive event. Some background to this. The dogmatists refer to Itokawa as a rubble pile. To them, a bunch of rocks and stones and dust just clumped together to form Itokawa. Mind you, this mamma jamma is traveling at around the velocity of 24 to 26 kilometers a second. Now, to put 24 to 25 kilometers a second into perspective, a high velocity rifle round travels around 1 kilometer a second. This thing is in orbit around the sun. I put a picture there for you. At 24 to 25 times the velocity, 26 times the velocity of a rifle round. We're boogieing here, right? As well, Itokawa weighs about 7 times the mass as the Great Pyramid of Giza. So imagine that rock flying around the sun at 25 times the velocity of a rifle round, and it's 7 times more massive than the Great Pyramid of Giza. There's no way that pebbles and stones and whatever clump together to make that object. And to put the kind of energy in perspective that that thing can produce, I did the kinetic energy formula, which is 1/2 times the mass times the velocity squared. So when you increase the velocity of an object, it increases its kinetic energy to the square, versus if you increase the mass, it only goes up a little bit. Basically, it means the faster you go, the more energy you gain per unit velocity. And the calculation is follows, and I have this in the paper, you can read it. We'll start out at walking pace. The amount of the similar amount of kinetic energy in joules is also I'm translating this into the amount of chemical energy released of TNT. So if this Itokawa object were at walking pace of around 2.23 miles an hour, which is 1 meter a second. If this object were to slam into something else traveling at a slow walking pace, it would release the kinetic energy of around 3.57 tons of TNT. So imagine 3 or 4 or 5 pallets worth of TNT. Imagine the kind of big blast that thing could take out. Pretty big explosion here. And that's just walking pace. The astronomers want you to believe that that's how the objects form, is that they just get really close together and then they touch and then they fuse or whatever and they melt. There's not going to be a lot of melting going on when you have that much energy inside of that, kinetic energy inside of that object. It, of course, is the abstraction. It's a concept. But mathematically, it means there ain't going to be any clumping when you have that kind of energy being spread out. You're going to have a big blast, and you're going to have a bunch of stuff fly out of it. And that's why there's a lot of space dust. That's why there are a lot of smaller pebbles in outer space, because objects like that slam into other objects and they make even smaller ones. Big rocks into smaller rocks. It doesn't go smaller rocks to big rocks to planets. That's reversed. The astronomers have it completely backwards. Next, we have the velocity of a NATO 5.56 round coming out of a rifle. So that's around 900 meters a second. That's the rifle all Marines are trained to use. Army personnel, Navy personnel. That's the ubiquitous assault rifle. But I don't look at it as assault rifle. That's just the rifle we're all trained to use. The round coming out of that 900 meters a second. If Itokawa were to be traveling at that, mind you, Itokawa is about 35 billion kilograms. So we're talking a big rock. If that were to hit something at the speed of a rifle round, it would be kinetic energy equivalent, or chemical energy equivalent of 3.375 megatons of TNT. So even at the relatively slow rate of a rifle round, if that thing were to slam into something, it would produce the chemical equivalent of 3.375 megatons of TNT. So a sizable nuclear warhead worth of an explosion. And that's just traveling at the speed of a rifle round. That's relatively slow. Now, with its actual velocity, and here's the kicker, that's 24,000 meters a second, faster or slower, so around 25,000 meters a second. The chemical equivalent TNT release would be about 2.4 gigatons. So we're talking about a massive explosion, something on the scale that we can't even replicate with earthly weapons. It's just impossible. But think about that for a second. The velocity that thing is traveling at in its orbit, the astronomers are claiming that thing was formed from rocks just clumping together. How the hell do you get rocks in orbit to clump together when it's traveling at 25 times the velocity of a rifle round coming out of a barrel of a gun? There's no freaking way that's possible. The reason why it has such a high velocity is because there was a previously orbiting object and there was an impact event, and it just maintained its angular momentum, its velocity, when it got ripped off the surface of the object, and it just kept on orbiting in the same spot. So we should expect wherever it came from to have a similar history. But I don't have that in the paper here. But just keep that in mind. The astronomers seem to not be able to comprehend the masses and the velocities of objects they're referring to. Because if they did, they would understand that that's not how something as massive as the Earth formed. And the Earth sits at around 6 sextillion tons, something like that. So you have, this is American terms, billion, trillion, quadrillion, quintillion, sextillion tons of rock. And they want you to believe that something like Itokawa, millions of Itokawas in outer space just all clumped together because of gravity alone. They don't realize how insane that sounds. For them all to know where to clump together, all in a specific point in outer space, all with the same angular velocity around the sun. What's even worse is I have it in another paper I wrote concerning how gas is supposedly accreted onto a gas giant. So a lot of the astronomers are saying, well, to form Jupiter, you need a rocky object, and then the gas just clumps together onto the rocky object over time. But that's not how gas behaves in a vacuum. Gas will naturally want to fill the vacuum. So there's no way to get the gas to clump together on something that's a higher pressure. It doesn't work like that. Gases move from the higher pressure to the lower pressure. They not only fill the container, they fill the space of the container itself. And when you have something as vast as outer space, there's no way you're going to get that gas to clump together to clump onto the rocky body, which is basically the same principle, because the gas particles are traveling fast, not only at high rates of velocity, but they're so freaking tiny that their mean free path is so huge. Oh, that's for another talk. But anyways, I'll link this paper to the bottom. Just think about how much energy is inside of these objects, and Itokawa is actually relatively small compared to the other larger asteroids and objects out there. It's really small. It's about like imagine a chubby Empire State Building. Like turn the Empire State Building on its side, or make the Empire State Building really chubby. I don't know how to describe it. But yeah, I have some extra stuff in here. But just keep that in mind. I don't think astronomers understand kinetic energy, because if they did, they would realize that planets can't form like that. That's just absurd. All right, guys, later.